Hopefully you're beginning to see classes and objects differently in a new light, seeing how to kind of conceptualize them as part of a larger machine rather than just individual objects. Hopefully you're beginning to see criteria emerge for important design decisions like where do I write my code or how do I structure my project. Object-oriented programming is all about boundaries and relationships and communication across those boundaries through the relationships that objects have with one another. So what I want to do now is actually shift gears a little bit away from very conceptual things and kind of look at this from a different facet and talk about the major tenets of object-oriented programming. The word tenet is not a word that we use frequently. It's defined as a principle or a belief, especially one of the main principles of a given religion or philosophy. And so we use the term tenet to express some of the highest guiding principles and concepts in object-oriented programming from which all of the other things flow that we'll learn about. And so there are three tenets of object-oriented programming. Some people would argue there's a fourth, and I agree, but I think that the fourth one will be covered as we talk about some of the others. So there's encapsulation, which we'll discuss further in this video, inheritance, which we'll spend a couple of videos on next, polymorphism, and then the fourth one that some people talk about is abstraction. And I agree, abstraction is a tenet, but it kind of comes at everything from a different axis, a different facet, and we'll see abstraction all around us. So I'm not sure I'm going to spend a whole video talking about it, other than to say that we've talked about abstracting in a number of different contexts already up to this point. Okay? So let's start with encapsulation. So encapsulation is a mechanism that's used to hide the implementation details of a class. And this will take several different forms. Fortunately, I think if you followed our curriculum on Developer University up to this point, you probably are already familiar with the mechanisms. In this video, I'm going to answer the why. Why is this an important tenet of object-oriented programming? But let's get back to the details. So first of all, a class, as you know, is made up of information, typically fields of information. And then also it's made up of functions, which we call in object-oriented programming parlance methods. And those functions or methods operate on the information, the fields, or use that information in some way to perform a task that we have delegated to it. It has a responsibility. We've delegated that responsibility. It's expressed in the form of mostly methods, and those methods will use some internal data that it's holding on to perform its responsibilities, its duties. Okay, so we encapsulate the information to be hidden from other classes, first of all. And so we restrict access to that information. How do we restrict access to fields? Well, we do that through the use of properties. So a property consists of two parts. As you'll recall, it has a getter and a setter. And they're really two methods, although they don't look like methods in the full definition of a property, but they are, in fact, methods. And we can use these property getters and setter methods as gatekeepers. They are gatekeepers in so much that they protect the data, the underlying fields of information, to ensure that, for example, the data is being set to a proper value within a certain range of accepted values. Perhaps from a getting standpoint, it's only available to people with certain permissions in the system. And so let's pop open Visual Studio. Finally going to write some code in this video. Here we have the beginnings of a little sample application. This is just a console application that I named Encapsulation Example. Feel free to pause the video and catch up with me. We're going to write some simple code here just to kind of flex our muscles and illustrate some of these ideas. And the first thing that I want to do is create a new car right here in the same file, or I'm sorry, a new class named car in this file. I'm just going to go class car, right? And we've done this 1,000 times probably up to this point. And what I want to do is type prop full tab, and that gives us a code snippet that will create a fully implemented property expression. And it will also create the underlying private field. So what we're doing here, the information is being held right now in my var. Maybe I should call that something more interesting, but I'll leave it as my var for the moment. It's an integer value. I'm not going to make any changes to it. My var is then revealed via a getter and a setter called property. So there's one name of the method. The method is known as my property, but depending on the context, we'll either call this sub method, I guess you could say, of get, or this sub method, I guess you could say, of set. All right, and it gives you a sample implementation, which is very straightforward. And as you know, we could do the same sort of thing by just going prop tab tab, and here we could go int my other property, right? And at this point, those two are roughly equivalent. You might be saying to yourself, but wait a second, we don't have the private field my var. That's correct. We basically have thrown away the notion of encapsulation whenever we go ahead and use a automatic implemented property like we do in most of our examples. But let's assume for the moment that we want to fully understand the full implementation and we want to see all of the parts fully exposed and not use this mere convenience that's been given to us in, I believe, C# 4.0 or 5.0 years ago. All right. So focusing on lines 18 through 24, at this point, we have encapsulated, we have hidden the access to my var through the use of getters and setters. Now, in this case, we're not really taking advantage of it, but I could right here say, only reveal this to users with certain rights in the system, right? So we might do some checks. If user dot, role equals admin, then we can go ahead and do that. Otherwise, we might return an exception. Now, here in the setter, we could do the same thing. We can evaluate and say, does this value make sense, right? We can protect our my var. So I might say if value is less than 0 or greater than 1,000, it just might, or 2,000, it just might not make sense for this application. I might throw an exception in that case. But if it falls within that range, then I'll go ahead and allow my var to be set. So again, gatekeepers to protect the private field. So that's the notion of encapsulation. We might also encapsulate all of the functionality of a method behind a couple of public methods. So we might break up a task that we delegate to a method into several helper methods. And we might do that for a number of different reasons, not the least of which is for readability or for just to keep things, I guess, scoped in a more manageable sort of way. And we can choose to hide the private implementation details using the word private and expose a one method that will make calls into those private methods, and we expose that and use the keyword public, right? And so in this particular case, we have a car here. Let's go ahead and do something like this. Public void display, and inside of here, I'll just do var value equals create display. And this is an unnecessary step, but I just want to make this very obvious. And then I'll go console dot write line, and we'll pass in the value that we received. Now we haven't created create display just yet. I'm going to hit Alt Enter on my keyboard, and I'm going to create a method called create display. And I'll go ahead and make that a string. Now you might see something a little bit different. I have a plugin called Resharper that makes some of these tasks a little bit easier in Visual Studio. You can just ignore that. Just make sure whatever you type is exactly what I type. Here what I want to do is actually I want to go return, and then we'll use string interpolation here, car, and then let's go my val, right? Or my var. Okay. So notice what I'm able to do here. I have created a private helper method. I'm not going to be able to access that helper method from outside of my car class. I've encapsulated all of the intelligence of the display method in one or more helper methods and hidden them, encapsulated them, but I do provide a public way of actually then calling into my display method, or to actually make it happen. Okay, so let's see here. Let's go up here now, and in static void main, I'll just go var car equals new car, and I'll even do this. We'll just go ahead and say my property, and I'll set that equal to the number 7. This is a very rudimentary example, obviously. So now what I may want to do is say, hey, I would really, really love to see the string that's going to get printed out, and maybe I could even get to that string first before it's printed out, make some changes to it, and then allow it to be printed out on a console.write line. However, since the car class has encapsulated our create display method using the private keyword, I do not have access to, what's the name of it again? Create display. As you know, I cannot get to create display. I'm going to have actually a compilation error here, and it's going to say it's inaccessible due to its protection level. It's been protected. The only way that I can get at it is to use its well-known public interface, car.display, and then I'll finish up here with console.readline. And what happens next is not all that exciting. I mean, I'm just going to print a little junk to the screen here. But the concept is what's important here, the concept of encapsulation. And the big question is, why is encapsulation important to object-oriented programming? Well, and why is it important kind of in the big picture of things, in the big picture of object collaboration design? Well, I guess I could draw an analogy. Have you ever had a nosy friend? Somebody who wants to know a little bit too much about your private life and maybe even wants to insert themselves into your private world. You might at some point in a moment of indiscretion drop your guard and share a bit too much about yourself or your past or your feelings with this person, but then later on you realize, man, that was a mistake. I shouldn't have done that. You share something private, but now you're worried that that person might share it or might use that information out of context or misconstrue the meaning of the events of your life. And obviously I'm over dramatizing here in order to make a point from the standpoint of object-oriented programming. We want our objects to have healthy relationships whenever they collaborate with each other. An object that shares too much information about its own implementation invites others to use the object in unintended ways. We don't want static void main to be able to get in and look at create display and change it in some way before it's actually displayed to screen. It may want to do that, but we have the final say because we are the information holder in the car object. We hold my var, okay? So, if I were to be, not take any great caution or care here, static void main might attempt to work around my intended implementation, or worse, it might form a dependency on an unintended implementation detail, like our helper method, create display, and as a result, its private implementation of its responsibilities are now tied to your object's private implementation of its responsibilities. In other words, if I were able to call into one of the private methods here, I could never replace car, or it would be difficult for me to replace this class with another class, because this code knows way too much about how this class does its job, and if I wanted to replace it and make my application more flexible in the future, I would be stymied because it knows too much about how the job is done under the hood, and I would have to make changes in multiple places in my code. All right, so that's what we're trying to avoid here. So if you try to replace this object with a new version, the entire application becomes broken. Why? Because the object that this interacts with knows way too much about the object that it's interacting with. It's abusing the proper contract of a work agreement. So your object should share as little as possible in order to do its work. This makes for a cleaner collaborative relationship between your object and other objects. It means your object can be more easily replaced with a different object that has the same basic interface in terms of the method signatures and such, but with a different implementation. So encapsulation is the first tenet of object-oriented programming. It contributes to helping us build more maintainable code because it enforces boundaries in a collaborative relationship. But encapsulation alone doesn't make a program object-oriented. There's more. Obviously, we need to cover some more tenets, and beyond that, learn more about all of the other principles and patterns that flow from these major tenets of object-oriented programming. So we'll pick up and talk about inheritance in the next video. Thanks.